People are always paying attention to carbs and fat when we're talking about ketosis, but we have to pay extra close attention to protein. It's the second most important thing that we really need to be worried about when we're on a ketogenic diet. And it all comes down to this fundamental thing that our body can do. It's called gluconeogenesis. Now, gluconeogenesis literally means new sugar. What that means is the body has an innate ability to create carbohydrates and create sugar, glucose, from proteins, from lactate, from glycerol, from non-sugar compounds that are in the body. So the body has the ability to create carbohydrates without carbohydrates even being present. You see, this happens at a very unique time. It happens when our glycogen stores are low. Now, for those of you that don't know, glycogen is the stored form of carbohydrate that is inside our muscles. Our muscles store carbs for later use. Okay, so when our glycogen levels are low, our body, when it's deprived of carbohydrates, will start trying to find a way to create carbohydrates from protein. Now, the other time that this can happen is when your protein levels are too high. If your protein intake is too high, the body will take that protein and convert it into sugar because it's easier for the body to use it that way than it is to have excess protein. The other time that your body can start breaking down protein and breaking down other non-sugar compounds into sugar is when you're under extreme amounts of stress. When you're under extreme amounts of stress, the body doesn't operate the way that it normally should. It's a little bit more inefficient and it throws all the irons into the fire at once to try to be able to create energy. So it's important that I debunk one myth really quick before I go any further into this. That myth is that you do not need carbohydrates to survive. Okay, there is some truth to that. But what the truth is that you don't need to eat carbohydrates to survive. Your body will always find a way to create carbohydrates because you will always have a metabolic demand for some carbohydrates, just a small amount. Your brain always requires 10 to 15% carbohydrates, whether you get that from food or whether you end up creating it from extra proteins or from your actual muscle tissue. So it's interesting, but your body always creates carbohydrates. Now, when we're in ketosis and we have enough ketone bodies present, the fat that is converted into ketones, it can slow down that process of your body creating sugar from protein. That's why it's very important that we keep those ketone bodies and that fat content very, very, very high. Okay, so let's talk about what happens with gluconeogenesis. Gluconeogenesis is said to be the opposite of glycolysis. And before you turn off this video because I'm talking about too many crazy words, let me give you a very simple breakdown. Glycolysis is when your body takes the stored carbohydrates that are normally in your muscles, takes them out of the muscles, and turns them into energy. Plain and simple. It's glucose that's stored in your muscles that gets released and turned into energy. That's glycolysis. When you work out, you're pulling the carbohydrates from your muscles and you're creating energy. So gluconeogenesis is essentially the opposite. It's energy getting converted back in to muscle glycogen or back into sugar. So in theory, it should be the direct opposite, right? You're basically just reversing the process. The problem is that when you create energy from carbohydrates, there are a couple irreversible steps, and that means that you can't just rewind the process. Best way that I can explain it is think about an old cassette tape or a VHS tape. Okay, you watch a movie, you get to the end of it. You would normally just rewind the movie and start it over if you wanted to watch it again. But you can't do that in the case of gluconeogenesis because there's irreversible steps. So you actually have to fast forward and loop all the way around and do all kinds of other hoops and barrels before you get back to the beginning again. You can't just reverse the process. Why am I telling you this? Because I'm telling you that the process of gluconeogenesis is a very inefficient process. It's not like you can just reverse that and create sugar again. So the point is, it requires a lot more protein to create 1 gram of sugar than it does to just eat 1 gram of sugar. So let me explain this with a study. There was a study that was published in the American Journal of Clinical Nutrition that took a look at 10 healthy males. And I want you to pay attention to this because this helps everything that I just said make a little bit more sense. Half of the males, they had eat a high protein, low carb, high fat diet. Okay? It was 30% protein, 0% carbohydrates, and 70% fat. Sounds a lot like the ketogenic diet. Okay? Then the other group, they had to eat a little bit more of a standard diet. 12% protein, 55% carbs, and about 33% coming from your overall fat. This is a little bit more like a standard American diet, somewhere in there. Okay, what they wanted to look at was the overall amount of energy expenditure after 1.5 days of eating these types of diets? Well, they found that the high protein, low carb group ended up having a 42% increase in energy expenditure. Now, energy expenditure doesn't mean they created more energy. Energy expenditure means that their body used more energy. So it means that their body was about 42% less efficient. So you might be wondering, well, wait a minute, that sounds like the ketogenic diet is bad. Well, there's a caveat. This was only 1.5 days. You're not in true ketosis for 3 to 4. So since they didn't have the ketones to actually buffer the process and the ketones to actually protect the body from using protein as a source of fuel, they proved that if you have higher amounts of protein, the body is taxed more because your body tries to create sugar from the protein via gluconeogenesis. So more protein stimulates the body to burn protein into sugar when carbs aren't present. The only way that you can stop protein from turning into sugar is to make sure that your fats are higher. I'm going to say that again. The only way that you can stop protein from getting converted into sugar is to keep your fats higher and to keep your fat ratio higher than your protein ratio by quite a bit, especially when you're in ketosis. Now, how does this have to do with actual ketosis? When you're in ketosis and you have high levels of ketones in the blood, your body's using those ketones instead of glucose, okay? But let's say you decide to go crazy on one meal and still remain ketogenic, but have like 12 ounces of steak or something. You just have a lot more protein, and you just so happen to have your fat content a little bit lower. Well, guess what? Your ketone bodies are going to temporarily drop, and your protein level is going to go up, which means that your body's going to use that protein and convert it into sugar, which means that you're going to potentially kick yourself out of ketosis. Now, I've done a lot of personal testing on this, and what I find is that right after a workout, I end up having higher levels of glucose and lower levels of ketones, sometimes even out of ketosis. Why? I'm under stress. I'm stressing my body out. So my body is breaking down my protein and turning it into sugar. Now, it's just temporary. I go right back into ketosis about a half an hour later, but pretty interesting. Now, another self-experiment that I've done is doing what I just described before. When I have a higher protein, lower fat meal with lunch, and then I measure my ketone levels. Guess what? Lower levels of ketones, sometimes even fully out of ketosis because my body has now taken all the extra protein and converted it into sugar. So that is why it's so important when I say that you pay more attention to the fat and don't worry about the protein. The fat is going to buffer your body's ability to convert that protein into sugar, meaning you're not going to waste as much muscle and you're not going to kick yourself out of ketosis and feel like crud. You don't want that 42% loss in energy. That explains why you feel so fatigued when you first go into ketosis, because your body doesn't have carbohydrates, but it has to use protein to try to create carbohydrates. So I hope that this helps clear some things up, because gluconeogenesis is a very complex process. And I'll be the first to say that there are components of gluconeogenesis that go beyond what I even know as far as biochemistry and what happens in the body goes. But this is a basic understanding of it and will help clear up a lot of things. And it might help you understand that a lot of the things that are published out there surrounding ketosis are not entirely accurate, because those proteins will kick you out. As always, keep it locked in here on my channel. Let me know if you have ideas for future videos surrounding the world of ketosis, fasting, and general health, and I will see you in the next video.